determine the probability that a randomly selected value fell within a group. That was a very useful thing to know. For example, consider this histogram, which probably represents a few hundred eggs. In the histogram, the probability that a randomly selected egg has a mass between 68.2 grams and 68.6 grams is 18.5%. That is the probability that it falls within the middle bar on the histogram. The probability that it is between 67.2 grams and 68.6 grams is 10.9% plus 16.3% plus 18.5% for a total of 45.7% probability. That is the probability that it falls within any of the three bars on the histogram. Now, let's have a look at a normal curve, a histogram with an infinite number of groups. The fact that the normal curve has an infinite number of groups might alarm you. The bars are infinitely thin on this histogram. How can you determine whether something falls within a group if there are an infinite number of groups between any 2 points? Don't let this bother you. On the perfect normal curve, you can select any 2 points and determine the probability that a value falls between them. To do this, you consult the normal table in the back of your textbook. The normal table assumes a perfect normal curve with its center at 0 and a standard deviation of 1. Want to know the probability that a point is between 1.0 and 0.0 on the curve? Look at the normal table in the back of your book, which gives the between 0 and something values. You should be able to find that probability is 0.3413 or 34.13%. Need to know the probability that a point is greater than 2.0 on the curve? Look at the normal table that gives the less than the left side or greater than the right side values. You should be able to find the probability is 0.0228 or 2.28%. You could use the same table to find the probability of being greater than 2.05, which is 0.0202 or 2.02%. Now I'd like you to try one on the perfect normal curve. What is the probability that a randomly selected point is between -1 and +1?